Let's do some computer vision. There is a fashion data set of clothing. These are grayscale images of clothing, and you can sort them into 10 categories, and they come with a label so you know what category they're in. So their 10 categories are t-shirts, trousers, dresses, coats, sneakers, bags, ankle boots, and it's going to sort those into the values. And so this should be 28 times 28. I somehow got some stupid complicated character that doesn't render correctly here. So each grid each image is a 28 by 28 pixel image. And so we need a more complex neural network like the one we had before. A single neuron is not going to do this. We're going to need layers of neurons. And I think here's a better diagram of it. So here, each input image is going to be broken up into pixels. There will be 28 times 28 of these, so several hundred. And each one of those is going to go to a hidden layer of neurons. And then all those each neuron is going to get input from all the pixels and be able to adjust all these weights. And then these neurons are going to feed to 10 output neurons, which are going to add up the result of those to decide what is the likelihood that it's a coat, a sneaker, a bag, or other things. So this is 2 layers of neural processing from the individual pixels. And we're not going to tell it how to do the job. It's going to learn how to do the job. So we're going to train the neural network. You have training images and training labels that you pull out of the data. So these are the known correct values and the images. And then you break it into 2 sets. You always do this. You have training images and you have test images. You take part of the data, like 20%, and set it aside to test the model. You train on 80%. And after you got a model, then you try to predict the 20% to see if it works. That's how you generally do this. And so here we make a model. The model is first going to have input layer of 28 by 28. So that's going to be all the incoming pixels. That's the input data. And there we go. And then we're going to have 128 neurons in the middle. These are the so-called hidden layer. This is the layer of neurons that is not connected directly to the input or the output. And the output layer is going to have 10 neurons, which are going to be the 10 categories. And so the idea is the weights of the interaction between these pixels and these neurons and these output neurons are going to be such that if you show it a picture of a shoe, it will light up the shoe output neuron more than the other things. So then you compile it, choosing various choices for which type of AI model it is, and then you fit it on the training images and you evaluate it on the test images. So that's the story. I'm going to go copy that. I'm going to get rid of my old one. I'm done with this one, so I do File, Move to Trash. Then Return to Co-Laboratory and New Notebook. Now I have a new one. You can save them in your Google account and come back to them, but I don't want to do that here. I just want them to be temporary. That's good enough. So I put in my code and I run it. It's preparing here, importing libraries and such. Now it's starting to run. You see at the bottom an executing thing showing it's executing, and there it goes. It's downloading data from this online data set of all those images, and then it's done getting the data. Now it's learning. Now this model is going to take quite a bit of time to learn each epoch, each training cycle, and it's going to use less training cycles, I think just 7 or something. So here's the accuracy and loss. The loss is 0.4, the loss is 0.3, the loss is 0.3, 0.30. As you see, it's doing the same thing. The error is going down. Loss is 0.2, and the accuracy is going up from 82% to 87%. All right, and so it's done. And so the final test on the test set was error of 0.3 and accuracy of 87%. So it got 87% of the test data right after this much training and that many neurons. All right. And so you can see 20 test images. To get a nice list of it, you can just add, that's why it's nice to use Python, a nice simple language. You can just print the results for 20 test images here. So I'm going to add another block of code and put it down here. All right. And so here's the chart for intent. Now these 10 columns represent the 10 possible categories from 0 through 9. And the right answer is the number to the left. So this one is really a number 9. And as you see, the weight of the outputs is 99 here and 0 everywhere else. So the correct neuron had most of the weight. And try and make this as big as I can. All right, so this one worked. The next one, you see, it's supposed to be a 2, and indeed the column 2 is big. This is supposed to be 1, and column 1 is big. So a lot of them worked. But since the accuracy was only like 87%, I should be able to find ones that failed. And this 7 worked. Well, no, I think this 7 is 8. This is 9, 8, 7. Okay. Should be able to find one that failed. That's 4, 6, 5. This one, 21 and 74. Okay, this one got close to failing. 0, 1, 2, 3, 4. It thought this one might be a 2, but a 4 is more likely. Here's one. This one it got wrong. 0, 1, 2, 3, 4, 5, 6, 7. It's really a 7, but it thought there was only a 12% chance of it being a 7 and a 76% chance of it being a 5. So this is one of the mistakes, that column. And there are other mistakes in here. As you see, if mistakes are going to be more than 1 in 10, she'll find them now and then. All right. And so we can print out those images to see. And I'm going to choose images where we had the error. So let me go here and make another code block and put in that stuff. And let's figure out which one had that mistake. It was one where the real answer was 7. It was this one. So let's just figure out which one that is. 0, 1, 2, 3, 4, 5, 6, 7. I think it might start at 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think that one is 13. We'll try that. Let's try item 13. I want to get the one where it got it wrong so we can print the picture, and let's see what it looks like. All right, here's the first one, which it got right, and here's the number 13, which it got wrong. It thought this might be a 5, and it's really a 7. And if I look at what the categories 5 and 7 are, there, 5 was coat and 7 was shirt. I think I should be using, so it really is a shirt, but it thought it was a coat, and I can certainly see how it would make that mistake. Can't tell if this is a shirt or a coat. All right, so that's what you see. It makes all kinds of sense. It's the ones that are confusing that it gets wrong. So it's doing a good job. All right. And so you can train it for more epochs to try to get it better. And one thing you notice if you train it more is that the accuracy on the training set goes up, but the accuracy on the test data doesn't really go up at all. In fact, if you overtrain your model, the accuracy on test data can even go down because it perfectly fits the training data, even fitting the details that are wrong in the training data, and gets less representative of the real world. And we'll see more of this as we go ahead. All right, and so there's some flags to find there, but that's all I have right now for that project.